Alright, so this is called Inverse Relations and Functions, page 164. Inverse relations and functions. Page 164. An inverse relation is when you have an ordered pair such as A comma B, and you flip-flop each term to get B comma A. So whatever basically was in your X spot is now over in Y's place, and whatever number you had at Y is now X, okay? You literally just flip-flop them. And then one is the inverse of the other, okay? Just like when we talk about the inverse of multiplication is division, okay? We say the opposite. It doesn't mean opposite. It means the inverse, okay? One undoes the other. If both a relation and by relation I just mean an ordered pair, and its inverse are both functions they are considered inverse functions. Remember, to be a function, comma, the domain, which are your X values, can not repeat. And I put vertical line tests, just to remind you what that means. And I'll talk about it again in a minute. Okay, so if the original equation that you start out with, if it is a function and you find its inverse is not necessarily a function, but sometimes it is. So if the equation that you're given is a function, and then we find the inverse and it is also a function, then we call those inverse functions. Now remember, to be a function, like if you saw the graph, you can't have any two places on the graph that, if you put a vertical line on the graph or a pencil vertically on the graph and place it anywhere on the graph, if it touched that vertical line in any two places or more, it's not a function, right? Y'all remember that? Okay, so let me just draw some examples of what is a function and what's not a function, just to kind of refresh your memory. If you had this graph, is that a function or not a function? Function. Because if you took a vertical line and placed it anywhere on the graph, there's no place where that graph crosses or touches your vertical line in two places. So that would be a function. Function, not a function. Not a function. Graphically, it does not pass my vertical line test. There's several places where it would touch my vertical line more than once. Okay? So not a function. Function, not a function. Function. Passes the vertical line test. Function, not a function. Not a function. We were getting graphs like that when we were graphing the rational functions. Well, not like that, because it wouldn't have been a function, but where it had like the weird curves in different places and stuff. So everybody remembers what a function means, right? Graphically, you know what a function is. Okay. If you had relation R, my domain is 1.2, 1.4, 1.6, 1.9. My range is I have a 1 and a 2. 1.2 goes with 1. 1.4 goes with 1. 1.6 goes with 2. And 1.9 goes with 2. This is a mapping diagram. It's just a different way to write ordered pairs, okay? If I'm looking at that and I'm like, is that a function or it's not a function? Me personally, I'm not always really good at just visualizing. I'm better if I can write it down and physically look and see if it's a function. Because to be a function, you cannot have any repeating x values. So if you see an x value more than once, just think if you plotted that on a graph and it has the same x value, you're going to have two different points on the same vertical line, right? So I like to write it out. So domain is x, range is y. Remember, domain, range. X comes first, then y. So if I wrote these out as ordered pairs, if x was 1.2, what is y? 1. If x is 1.4, what is y? 1. If x is 1.6, what is y? 2. If x is 1.9, what is y? 2. If I were to graph this, would it be a function? Yes. It has repeating ranges, not domains. If you have two ordered pairs that have the same y value, they're going to be on the same horizontal line. That doesn't matter. That doesn't make it not a function. If they're on the same vertical line, that makes it not a function. So since none of your domains repeated, This would be called a function. Now, if I asked you to find the inverse, literally all you do is switch the x and the y. So your range will now become your domain, and your domain will now become your range. Okay? So if I said, well, what's the inverse of relation R? The inverse of relation R, my domain will now be the 1 and the 2. And then my range will now be 1.2, 1.4, 1.6, and 1.9. And the numbers still go with whatever they did previously, okay? So 1 still goes with 1.2. 1 also goes with 1.4. 2 goes with 1.6 and also with 1.9. You think that's a function? Nope, it's not. Let me write out the ordered pairs. You have 1 comma 1.2, 1 comma 1.4. Right there, we have two repeating domain, right? So automatically not a function. We have 2 comma 1.6 and 2 comma 1.9. Not a function. So if I said, are these inverse functions, you would say no. Because if you go back up and look at your definition above, it says to be an inverse function, both your relation and its inverse both have to be a function. Okay, if they're both functions, then they're called inverse functions. These are not. I'm going to say these two functions, well, no, they're not actually functions. These two relations are not inverse functions. Okay. All right, page 132. 165. Old book was 132. New book 165. What is the inverse of relation S? So this time I'm going to give you a table of values, not a mapping diagram, but a table of values. Relation S, little table of values. My x's are 0, 2, 3, and 4. And my y's are -1, 0, 2, and 3. Is that relation a function? Yeah. have no repeating domains, right? 0, 2, 3, and 4, that never repeats. Does not matter if your range repeats. Does not matter. It's all about the domain. So if I said, what is the inverse of relation S? Instead of 0, -1, what would we put? -1, 0. Instead of 2, 0, 0, 2. Instead of 3, 2, 2, 3. And instead of 4, 3, 3, 4. Is your inverse of relation S a function? Yeah. So if your original relation and its inverse are both function, then we refer to these as inverse functions. You have a question? It's tough stuff, right? So complicated. All right, next thing I'm going to show you is we're going to graph relation S and the inverse of relation S. And the cool thing is it already gave me the ordered pairs, so literally I just am going to make two separate graphs, hand-drawn, and plot the points on there, okay? So I'm showing you how that you can look at a table of values and find the inverse, how you could graph the inverse, and then I'm going to show you with how to, if you're given the equation, instead of just given ordered pairs, if you're given the equation and you have to inverse, what to do there, okay? But now I'm just going to start with relation S. All right, so let me get some. I need to graph 0, -1. When x is 0, y is -1. When x is 2, y is 0. When x is 3, y is 2. And when x is 4, y is 3. So graphically, can you see that that's a function? Yeah. No two points will end up on the same vertical line. So I'm just going to put relation S function. And then I'm going to graph the inverse of relation F. So when x is -1, y is 0. When x is 0, y is 2. When x is 2, y is 3. And when x is 3, y is 4. Can you see graphically how that is also a function? Yeah, okay. Passes the vertical line test. All right, so now let's get to the fun stuff. Sometimes you're going to be giving an equation, not a graph, not a table of values, not a mapping diagram, but an equation, and you're going to have to say what the inverse is. All right? You might have questions so far? So far, pretty easy. Page 166. Find an equation of the inverse. What is the inverse for the relation described? And my equation is y equals x squared minus 1. So say it again. Well, I'm glad you're thinking about it. You know how with the mapping diagram or the table of values or the graph, we've switched x and y? We're going to do the same thing here. We're just going to switch the x and the y. Unfortunately, you have to do more than that. Switch the x and y, and you isolate the y all over again. So like you start with a y isolated. Wherever you see a y, put an x. Wherever you see an x, put a y. And then just solve for y all over again. Of course, I'm going to make a little note of that. Since we flip-flop the x and y to find the inverse of a relation, we will do the same thing to find the inverse of an equation. Okay, first of all, y equals x squared minus 1. What kind of graph is that going to make? Quadratic, right? So it's a parabola. So going to open up or down? Going to open up. Is that a function? Yeah, it's a function. Yeah. Going to look like this. Right? Function. Quadratics are always functions. But we don't know if the inverse is going to be a function. But we're going to find out. So wherever I see an x, I'll put a y. Wherever I see a y, I'll put an x. So this will become x equals y squared minus 1. That's not where you stop. Now we got to isolate the y all over again. Okay? And that's always going to be different. Each problem is going to be different. I can't possibly give you an example of every problem you're going to come across. You just have to look at it and say, what can I do to get this y all by itself? So in this case, what's the first thing we're going to do to start trying to get y by itself? Subtract, or what? Add 1 to both sides. So on the left side, we have x plus 1 equals y squared. Have we solved for y? No, we've solved for y squared. What's the inverse of squaring something? Square rooting it. And remember, when you take the square root, you take the positive and negative square root. Not the y squared, but the other side. Can I take the square root of x plus 1? No, that's just one. X plus 1, that's one factor. To take the square root, I would need like x plus 1 quantity squared or something. I would need 2 identical factors. This is just 1. What's the square root of y squared? Y. So y equals plus or minus the square root of x plus 1. Do you think that's going to be a function? If x is 3, what's 3 plus 1? 4. What's the square root of 4? Positive 2 or negative 2. So my ordered pair there would be 3 comma 2, 3 comma negative 2, right? Is that going to be a function? Has a repeating domain. So we know that we started with a function. The inverse is not going to be a function. Because of the way I just described. Do you want me to put in a little example as to why it's not? Okay, I will. So if x equals 3, then y equals positive or negative the square root of 3 plus 1. That's positive, negative the square root of 4, which is positive or negative 2. So when x, we would have x comma 3. Sorry, that looks weird. No. I'm sorry. We'd have 3 comma 2 and 3 comma negative 2. Obviously, that's not the only example. That's just one example of what can't be a function. Has a repeating domain. Because you have that positive and negative on the outside. So I can give you 2 different answers when you plug in a value for x. Or substitute in a value for x. Does that make sense? So that square root thing's kind of the reason why. So let me show you graphically what this would look like. We know how to graph y equals x squared minus 1. If you don't remember how to graph something, just make a table of values. Okay, and go from there. If the numbers that you choose for the table of values, if that's not making you a good graph, then keep on finding some more numbers. So let's graph the original y equals x squared minus 1 first. And I like to start, when I'm trying to graph, I just start with negative 2, negative 1, 0, 1, and 2. Oh, sorry. And since this is kind of easy, I'm just going to do it in my head. Okay? So if I substitute in negative 2, what's negative 2 quantity squared? 4. And it's positive. 4 minus 1 is 3. What's negative 1 quantity squared? 1. 1 minus 1 is 0. Let's plug in a 0. 0 squared is 0 minus 1? Negative 1. Substitute in a 1. 1 squared is 1 minus 1? 0. Substitute in a 2. 2 squared? 4 minus 1? 3. I have repeating ranges here, but does that make it not a function? No. So at least the ordered pairs that we can see right now, it looks like a function, which we already know it is because quadratics are always functions. Now, when we found the inverse of that, we already know it's not a function, but let's see what the graph's going to look like. Do you think it's going to look similar to this? You think it'll have the same shape? It'll have the same shape, it'll just be in a different location, okay? And just because it opens up doesn't mean it opens down, because if a parabola just opens down, well, that's a function, all right? So let's take the equation, y equals positive or negative square root of x plus 1. And I'm going to start at the same place I did before. Well, actually, you know what you can do? Do I even need to plug stuff in, or can I just use the same ordered pairs we had over here? I can use the same ordered pairs. I'm just going to flip-flop them, okay? If you want to, you could go ahead and substitute them into the equation. You can do that, but you're going to get the same thing as if you just went over here and flip-flop. So instead of negative 2 comma 3, 3 comma negative 2. Instead of negative 1 comma 0, 0 comma negative 1. Instead of 0 comma negative 1, negative 1 comma 0. Instead of 1 comma 0, 0 comma 1. Instead of 2 comma 3, 3 comma 2. Like I said, you can plug those numbers in over here if you would like, but you don't have to. If you already have ordered pairs, just flip-flop them, and that's your inverse. So when x is positive 3, y is negative 2. When x is 0, y is negative 1. When x is negative 1, y is 0. When x is 0, y is 1. When x is 3, y is 2. Is that a function? No. Does not pass the vertical line test. Not a function. Which we already knew it was not going to be a function. Now on that one, if you would have started out using negative 2, negative 1, 0, 1, and 2, you could have done that. When I taught it last year, that's what I did. And I got imaginary numbers and weird numbers here, and I had to keep going to find other numbers that I could plot on my graph. Okay, I did it the hard way. No need in going through all that. If you already have the ordered pairs of your original inverse, you know you just have to flip them, and that's going to give you the ordered pairs of the inverse. All right? Anybody have questions? Okay. Page 167. Y'all might want to think about starting to buy yourself another spiral. If you don't want to do that, I totally understand, because we're not going to get very far in the new spiral. If you just want to use notebook paper and maybe just like make you a pocket in the back or staple it or something, totally up to you. But we will need something extra because we'll get through a whole spiral. Example, find the inverse. And we're not going to graph all of these. I just wanted to show you in that first example what you would do to graph it. All right, y equals 2x plus 8. What's that going to be if I were to graph it? Linear. Be a line, right? Is a line going to be a function? Yeah, unless it's a vertical line. And if it was a vertical line, it would only be x equals some number, okay? So any other line is going to be a function. So we know that's a function. If I were to graph it, what was my y-intercept? 8, what would my slope be? 2 over 1. But we're not going to. But if I was, we know what it would be. So if I'm finding the inverse, first thing I'm going to do, flip-flop the x and the y. And after I do that, what's my goal? Yeah, I need to solve for y, or isolate the y, however you want to say it. So in this case, what will I do first? See what? Subtract 8 from both sides. And I get x minus 8 equals to y. Divide by 2. So on the right side, I have y. On the left side, now me personally, I would probably divide those separately because I can write it as y equals x minus 8 divided by 2. But I like to separate it, especially if I want to go and graph that. So I'm going to go and put the y on the left. And that's the same thing as x divided 2 minus 8 divided by 2. Still don't like the way that's written. X divided by 2. Isn't that the same as 1/2 x? Right? And negative 8 divided by 2 is what? Negative 4. What would that look like if I were to graph it? What would it be? A line, a parabola, a line, right? What's my y-intercept? Negative 4. What's my slope? 1/2. Is it going to be a function? Yeah. So are these inverse functions? Yeah. Not that it asks, just showing you another example of an inverse function. Sometimes they'll both be functions, sometimes they won't be functions. Sometimes your original problem will be written as f of x. Remember, f of x means it is a function. But just because your original is written as f of x, the inverse, if it's not a function, you can't use the f of x notation. If it's not a function, you can't use f of x. You have to use y. All right? Which we'll see more of that in a minute. Next example. Anybody have questions on that one? All right, we're moving right along. Y equals, open parentheses, 3x minus 4 quantity squared. If I'm finding the inverse, what do I do first? Switch the x and the y. So we have x equals, open parentheses, 3y minus 4 quantity squared. Yeah. So, how can I get rid of that squared? Square root, right? We learned that. Now, on this side, not the side we're trying to isolate, but on the other side, if we're taking the even root, which we are, make sure you take the positive and negative, okay? We don't do that on the side we're trying to isolate. And y'all know I could have written the parentheses inside with the squared or outside with the squared. It means the same thing. Can we take the square root of x? No. So we have positive, negative, square root of x equals, what's the square root of 3y minus 4 quantity squared? 3y minus 4. What do you think I'm going to do now to solve for y? What? Add 4. Can I add 4 to the x that's under the radical? No, because it's not the square root of 4. It's just 4. So it's 4 plus or minus the square root of x. That means 4 plus the square root of x and 4 minus the square root of x equals 3y. Divide by 3. I can divide the whole thing by 3. I can do it separately. And so I got y equals 4 plus or minus the square root of x all over 3. Remember, that means 4 plus the square root of x over 3 and 4 minus the square root of x over 3. Is this going to be a function? If I substitute in a 4 for x, what's the square root of 4? 2. Positive 2 and negative 2. So when we do simplify all that, you're going to get 2 different values, right? When x is 2, you get 2 different y values. So is that a function? No. Was my original a function? Yeah, it's a quadratic. My highest degree is a 2. Quadratic's always a function. The inverse of a quadratic's never going to be a function because it's always going to be like the sideways looking parabola if we graphed it, all right? A quadratic, up or down, function. The inverse is going to be sideways, not a function. Not a function. It's going to be sideways. See if I can put another one into the right. Let's do y equals, open parentheses, 1 minus 2x, close parentheses, quantity squared, plus 5. Change x and y. Oh, by the way, I know this is a quadratic because my highest degree is a 2. Even though it looks weird, right? We could simplify that out. Do 1 minus 2x times 1 minus 2x, FOIL it, and then add 5. If we did all that, it'd be a quadratic. But because x's highest degree is a 2, we already know it's a quadratic. It's just not simplified very pretty. So we know that's a function. Now I want to try to isolate the y. What should I do first? Okay. So x minus 5 equals 1 minus 2y quantity squared. Now what? Mm-hmm. And I took the, like she said, I did the positive and negative because if it's an even index, you do positive and negative, but not on the side that has the variable that you're trying to isolate. It's always on the other side. Can I take the square root of x minus 5? No. So I'll just rewrite that, positive or negative, square root of x minus 5. What's the square root of 1 minus 2y quantity squared? What's the square root of 1 minus 2y quantity? Just 1 minus 2y. And remember, on these, we're not trying to solve for x. We're just trying to get y isolated. Okay, we're trying to find a new equation. What? Subtract the 1. Can I subtract it from the 5 that's under the radical? No, because 1 is not under a radical. So I have negative 1 plus or minus the square root of x minus 5 equals, and that is a negative 2y. Divide by negative 2. I can divide this term separately from this term, or, because I'm not going to be able to simplify that much, I can divide the whole thing. So I'm going to go ahead and put y on the left. Y equals, now I cannot have a negative in the denominator, okay? So if I move it to the numerator, negative 1 divided by negative 2, what's a negative divided by a negative? A positive. So that will become positive. And here, with the second term, since I have both signs, a positive divided by a negative is a negative divided by a negative is a positive. So it already has 2 signs, so that doesn't make a difference. but you don't want to leave that denominator as a negative. Is that going to be a function? No, whenever that x is under a square root and you got a positive and negative on the outside, whatever I plug in for x, I'm going to get two different answers for y, okay? So that is also not a function. Remember, we call them inverse functions if your original is a function and the inverse is a function. If they're not, if one of them's not, they're not inverses. I have one more example. You have a problem? You're tired? What? I don't know what you're saying. We'll talk about it later. All right, page 168. The inverse of function f is denoted by f, and it's raised to the negative 1, okay? But you don't say f to the negative 1. You read, and I'm going to say it like f to the negative 1 for now because that's all you know, but that's not how you say it. You read that as the inverse of f or you could say f inverse. And then I made another little important statement. The notation f of x is used for functions but the relation inverse of f may not be a function, which we saw that. And you can't use function notation if a relation is not a function. So I have f of x equals the square root of x minus 2. That's the way the problem is given to you. Is that a function? Yeah. Even though x is under the radical, it is a function because it doesn't have the positive negative out there, okay? So if you were to graph this, it would only be like the top half of the sideways parabola, okay? If it was positive or negative, that's when you would get the bottom half of the sideways parabola. But if you don't have that out there, then it's only just one side of it, okay? So would that be a function? Yeah. So this is a function. And if I want to take the inverse, f of x is the same thing as y, right? So the first thing I'm going to do is I'm just, instead of writing f of x, I'm just going to write it as a y instead. I have not switched anything. There's been no flip-flopping going on. But instead of using f of x, I just replaced it with a y. When you use y doesn't mean it's a function or not a function. Okay, y will work for a function or not a function. F of x, you can only use f of x if it is a function. All right, so now I will switch them. And I want to get y by itself. Can I just add 2 to both sides? I will square both sides. So x raised to the second power is x squared equals, what is the square root of y minus 2 quantity squared? Y minus 2. Then what? Add 2 to both sides. So x squared plus 2 equals y. And because this gave it to me in function notation, is the inverse a function? It's a quadratic, right? If I plug in a 2 for x, am I going to get 2 different y values? No. So this is a function. So if it started in function notation and it wound up being a function, I don't call it inverse of f. I don't call it f of x. I call it inverse of f equals x squared plus 2. If it started with f of x and it ended up being a function, I don't want to leave it as y equals x squared plus 2. I want to write it as inverse of f, or you could say f inverse equals x squared plus 2. Anybody have a question about that? Everybody good? Okay. Let me pause this and I will get your homework.